Right, guys, let's take a look at the normal distribution, right? This is a very popular question in the exams, normal distribution. So let's take a basic look. So what is the normal distribution? So let's say, for example, I draw a graph, and on this graph, I just want to represent the heights of men in Ireland, right? So we've got the height here, and let's say on the vertical axis, we've got the number of men, all right? So we're just trying to create a graph that shows the heights of men in Ireland. So in Ireland, the average height of a man is about 177 centimeters. All right. So if we were to draw a bar chart, there's more men with a height of 177 centimeters than any other height. Then as you start to go above average, so you go to 180, 185, so on, 190, there's less and less men at those heights. So as you keep going higher and higher, as you get to 6 foot, 6'6", so on, there's less and less men that have that height. And same as you go shorter. As you come shorter, down to 170 centimeters, 165 centimeters, and so on, there's less and less men at that height as well. So this makes sense, right? There's more men at average height than there is really tall. So all the really tall people are here, and the shorter men are down here. And then in the middle, you have the average, right? So there's more men around average height, there's less tall men, less short men. And that makes sense. That's normal, right? That's normal, hence why we call it the normal distribution. And that's not just true for height, it's true for weight, IQ scores, loads of different things have a normal distribution. And what we do, rather than drawing a bar chart, if we make those bars as narrow as possible, it basically creates this curve. We call that, you might have heard the bell curve. All right, I'm sure you've heard that before. So the bell curve is your curve that mimics this normal distribution of certain variables. So this is where it all comes from, all right? So that's what a normal distribution is. And generally there's two things you care about when you're looking at something that's normally distributed. You care about the average. So in this case, the average was 177. And we also care about the standard deviation. We use sigma as our symbol for the standard deviation. And the standard deviation is just a measure of how spread out the data is. Were most people around 177, or was there lots of tall people and lots of short people? So the standard deviation can tell you that. So the standard deviation is just a measure of how spread out it is. The bigger the standard deviation, the more spread out the curve actually is. The next thing to look at then is the standard normal distribution. So we have a standard normal distribution curve. And the mean of this curve is 0 and the standard deviation is 1. All right, so that means the value in the center of the curve, remember that's the mean or the average, that's 0. So this right here is 0 and the standard deviation is set to 1. The axis that we have here, we call that the z-axis. All right, z-axis. So you've got 1, 2, 3, minus 1, minus 2, minus 3. All right, so we generally only care about values between -3 and 3, and each of these units represent one standard deviation. So when you go up 1 unit on the z-axis, you're 1 standard deviation away from the mean, 2 standard deviations away from the mean, 3 standard deviations away from the mean, etc., etc. So what's important to understand is the way we have set up this standard normal distribution curve is that the area underneath the curve, if I was to calculate that total area, the total area underneath the curve is equals to 1. So then we can connect this to probabilities and proportions because, the sum of all probabilities adds up to 1. So this represents 100% of our data if it totals up to 1. What we need to be able to do is understand the connection between the values you have on the z-axis and the areas underneath the curve. And to use that, we use our normal distribution tables that you can see here. These are on page 36 of your log tables, but I'll actually upload these 2 images as well. So if you don't have your log tables, you can just use these 2 images. All right. So what you can see from the log tables is you have these values in bold. The values in bold that are across the top and down the side, they're the Z values. So they're the values that you have on your Z axis. And then what you have in here, the decimal place values, they're all 4 decimal place values. They're all areas. So what you have in there are areas. All right. So what this does, if you look up a particular Z value, it tells you the area up until that Z value. So for example, if you look up the Z value of 1, you get an answer of 0.0 0.8413. So that's telling you the area underneath the curve as far as 1, that whole area there is 0.8413. That's how these work, okay? So it's very important to understand how the connection between the Z values and the areas. So we'll do a couple of examples just to make sure you get it. Right, so let's say this question 2 here. I want to find this area. So we want to find the blue area. So basically the Z value is 0.64 and I want to find the area underneath the curve up until the Z value of 0.64. Now remember that 0 is in the middle, you know, so this is to the right of 0. Obviously 0.64 is above 0. So that's exactly how the tables work, all right? That's going to be very easy. Just take your tables and I look up the Z value of 0.64. So I go to 0.6, then across to 4, and there's my value. Now that's 0.7389. So 0.7389. And that's exactly what that area is. 0.7389. So that's exactly how the Z tables work. You look up the Z value and it tells you the area up until that Z value. All right, moving along. Let's say I wanted to do one like this. So in this case, I want to find the blue area here above 1.37. All right. So we take our Z tables and first of all, we locate 1.37. So 1.3 and across to 7, we have it there, 0.9147. Right. That's 0.9147. All right. Now, the thing is to remember how the Z tables work. That tells you the area up until that Z value. So 0.9147 is the area until 1.37. We're looking at the area after that. So we remember that the total area is 1. So the answer that we're looking for the area that we're looking for, it's 1 minus 0.9147. And that gives us 0.0853. So that's our answer to that particular question. So if we're trying to get the small corner area, we have to remember to take our answer away from 1 because the Z tables always tell us the bigger area underneath the curve until that Z value, if it is a positive Z value. All right, let's take a look at this one here. So in this one, we want to get the area above the Z value of negative 1.09. So we need to understand that if you look at your Z tables, you don't have any negative Z values. You only have positive Z values. So here we have to understand the symmetry of the standard normal distribution. So from minus 1.09. So I'll leave that aside for a second. So what we're trying to find is the area from minus 1.09 upwards, that whole area there. So we need to understand the symmetry here, that area is in fact exactly the same as the area from 1.09 the other way. All right, so those two areas are the same. So in fact, we'll get the area from 1.09 to the left, and that's the same as the area from minus 1.09 to the right because it's exactly symmetrical. So we look up our value of 1.09. So I need to get the other table. So go to 1.0 and then across to 9. So 0.8621, 0.8621. That area there is 0.8621. Therefore, the area we're looking for above is also 0.8621. So that's it for the basic introduction to the standard normal distribution. The next thing now would be to practice the curves and practice the Z tables and getting the area underneath the curve. So there's some questions there for you guys to try and you will see the solutions attached.